Hello everyone, good evening. So here we shall solve from question number 56 onwards. So here it is told that triangle ABC is a right angle. Triangle ABC is a right angle, which is right angled at A. So this is the right angle ABC. So triangle angle A is the right angle such that AB equals to AC, and the bisector of AC, it intersects the side AB at D, and prove that AC plus AD, that is equal to BC. So this is the right angle and this is the bisector. It means these two angles are equal. So now first we will write what is given. So given is that in triangle ABC, angle A is a right angle which is 90 degree, such that AB equals to AC, and the bisector of angle C meets the side or intersects the side AB at D. We have to prove that AC plus AD, that is equal to BC. So now here we need one construction. So the construction is we have to extend CA to the point E such that AE equals to AD. And then we have to join D. So the construction, we will write that CA is extended. Line CA is extended to E such that AD equals to AE, and line segment DE is drawn. Then we'll write the proof. Proof is we'll write that now in so these two angles are equal. These two triangles, this side is common. Okay, so I can say that in triangle ABC, angle B equals to angle C. Means why? The angles opposite to the equal sides are also equal. Angles opposite to the equal sides of a triangle. Angles opposite to equal sides of a triangle are also equal. So now we can say that angle A plus angle B plus angle C, that is equal to 180 degree by the angle sum property of a triangle. So now angle A is 90 degree and angle B and angle C are same. So I can say twice of angle B, that is equal to 180 degree. So hence I can say that angle B will be equal to 90 degree divided by 2, that is 45 degree, which is also equal to angle C. So now also we can see now angle ACD, that is equal to angle BCD, that is equal to half of angle C. Since it is given that CD is the bisector of angle C. Since it is given that DC is the bisector. DC is the bisector of angle C. So therefore, I can say that angle ACD equals to angle BCD, that will be equal to half of 45 degree. That is 22.5 degree. 22.5 degree. And also I can see that in triangle AET or triangle ADE, AD equals to AE, AD equals to AE, which is according to the construction. According to construction, so I can say that angle ADE, that will be equal to angle AED. Is equal to 180 minus 180 degree minus angle A divided by 2, which is equal to 90 degree divided by 2, that is 45 degree. Since why? Since I can say that since angle BAD, sorry, angle BAC, first we have to write this actually. We have to write this. So first we will write that angle BAC plus angle BAE, that is equal to 180 degrees. BAC plus BAE, that is equal to 180 degrees, since it is forming a linear pair. It's forming a linear pair. Now I can say that angle BAC plus angle BAE, that is equal to 180 degree. Okay. So now BAC, that is 90 degrees. So therefore I can say angle BAE, that will be also equal to 90 degrees. Now we can say that angle AET plus angle ADE plus angle DAE, and BAE and DAE is the same thing actually, plus angle DAE, ADE plus DAE, that is equal to 180 degree, since it is according to the angle sum property of a triangle. So therefore now this now AD, now AET, that is equal to angle ADE, since it is told since according to the construction AD is equal to AE, so the angles opposite to the equal sides are also equal. The angles opposite to the equal sides of a triangle are also equal. And angle DAE is 90 degrees, so therefore I can say angle DAE plus is equal to angle ADE, that will be equal to 180 degree minus 90 degree divided by 2, that is equal to 45 degree. So here also each one is 45 degree. So this one is also 45 degree, this one is also 45 degree. This is 22.5 we have proved, and this is also 22.5 degree. So now we can say, now in triangle CDE, triangle CDE and triangle CDB, triangle CDE and triangle CDB, angle CED, angle CED, that is equal to angle CBD. CED equal to CBD, which is 45 degree, which has been proved above, which is proved above. And angle ECD, that is equal to BCD. And angle ECD, that is equal to angle BCD, which is equal to 22.5 degree, which is half of 45 degree, which is also proved above. Also proved above. And CD is the common side. And CD is the common side. CD is the common side. So I can say that triangle CED, triangle CDE is congruent to triangle CDB by angle side. Means two angles and the non-included side are equal. So I will say by AS rule of congruency, AS rule of congruency, these two triangles are congruent. So therefore I can say that CE, that is equal to CB. Therefore I can say CB equal to CE by CPCT. So CB equal to CE by CPCT. Therefore we can say CE equal to CB by CPCT. Now we can see that CE it means it is CA plus AE. CA plus AE. CA plus AE. And AE is equal to AD also, which is according to construction. And CA and AE is equal to AD, which is according to the construction. So therefore we can say that CE is equal to CA plus AD. CA plus AD. Now CE is equal to CB. So therefore I can say that CB is equal to AC plus AD. CB is equal to AC plus AD, or I can say that AC plus AD, AC plus AD, that is equal to BC. So hence proved. Then here it is told in the given figure OA equals to OB, OA equals to OB, and OP is equal to OQ. Prove that PX equals to QX and AX equals to PX. So now first we will write given that in triangle AOQ and triangle BOP, BP is perpendicular to AO and AQ is no, it is not perpendicular. It's not like that. Okay. So in triangle AOQ and BOP, P and Q are points. P and Q are points on the sides. The sides AO and BO respectively. BO respectively. Does that AQ and BQ intersect? Sorry, AQ and BP intersect at X. Intersect at X such that OA equals to OB and OP equals to OQ. OP equals to OQ. equals to. Now we have to prove that first is Px equals to Qx, Px equals to Qx. Second is Ax equals to Bx, Ax equals to Px equals to Qx, and Ax equals to Bx, Ax equals to Bx. We have to prove it. So the proof is like this, that we'll say that in triangle AOQ and triangle BOP, we have that angle AOQ that will be equal to angle BOP. Since why? Since angle O is common in both the triangles, angle O is common, and AO is equal to BO is given, and obviously OQ is equal to OP is also given. So it means we have taken two sides in the interior angle are same. So it means therefore I can say that triangle AOQ is congruent to triangle BOP by SAS rule of congruency. SAS rule of congruency. So therefore I can say that angle OAQ that is equal to angle OBP, right? CBCT. So hence we can say, hence we can also say that and also we can say that this AQO that is equal to BPO, angle AQO that is equal to angle BPO, AQO that is equal to BPO by CBCT. So therefore we can also say that means that angle PAX, angle PAX that is equal to angle, since why OAQ is same as angle PAX and OBP is same as angle QBX, angle QBX. So it means that PAX is equal to QBX. This, since I will say, since angle, we have proved that angle OAQ is equal to angle OBP. OAQ is equal to angle OBP. Here we can draw it also. Okay. So now this is OAQ. Okay, fine. So this is the common angle. These also are equal. We have proved it. These angles are also same. We have proved it. Okay. So now, and these two will be vertically opposite angles, so they will be same. And it is also given that x. Yeah. Okay. Now it is given that OA is equal to OB. OA is equal to OB. It means that OP plus AP. OP plus AP. Since OA is OP plus AP, that is equal to OB, which means OQ plus BQ. P plus BQ. Now OP is equal to OQ. Now OP is equal to OQ also, which is given. This is also given. So these two I can cancel out, and therefore I can also say that AP is equal to BQ. AP is equal to BQ. So now I can say that in triangle PAX, triangle PAX and triangle QBX. Angle PAX is equal to angle QBX, which we have proved above. And angle BXQ is equal to angle PXA, or I can say AXP. Since why they are vertically opposite angles. If they are vertically opposite angles, they are equal. And can say AP, that is equal to BQ, which is also proved above. So we have shown that two angles and the non-included side in these two triangles are equal. So therefore, I can say that triangle PAX is congruent to triangle QBX by AAS rule, by angle side rule of congruency. The AAS rule of congruency. So now we can say that AX, we can say that PX is equal to QX. We can say PX is equal to QX, and we can also say that AX is equal to PX, which is by CPCT. So hence proof. Then here it is told in the given figure, ABC is an equilateral triangle. ABC is an equilateral triangle. So each of the angles are 60 degrees. PQ is parallel to AC. Okay, so the given we will write that in equilateral triangle ABC, PQ is parallel to AC and AC is produced to R such that CR is equal to BP. CR is equal to BP. We have to prove that QR bisects the line segment PC. QR bisects PC. So the proof is, you can see that now in triangle ABC, I can say that angle A equals to angle B equals angle A plus angle B plus angle C, that is equal to 180 degree, which is the angle sum property of a triangle. And angle A is equal to angle B is equal to angle C. Since it is given that since triangle ABC is equilateral, it is told. Therefore, so I can say that angle A equals to angle B equal to angle C equals to 180 degree divided by 3 is equal to 60 degree. Also, it is given that QP is parallel to AC. It is given. So we can say that angle BPC or angle BPQ, that is equal to angle BCA, will be equal to 60 degree. Since they are corresponding angles. Since PQ is parallel to AC, since I can say since PQ is parallel to CA and PC is the transversal. PC is transversal. And we can also see that angle BQP, that will be equal to angle BSC, which is equal to 60 degrees. Since why they are corresponding angles, since PQ is parallel to CA and BC is the transversal. BC is the transversal. This is 60 degree. So therefore, I can see, therefore, in triangle BPQ also, in triangle BPQ, angle BPQ is equal to, it is coming, angle BQP. BPQ is equal to BPQP is equal to 60 degree. And so, so we can say that the remaining angle, which is the third angle, B, which is angle B, that will be equal to angle B, or I can say angle PBQ, angle PBQ, that will also be equal to 180 degree minus 60 degree plus 60 degree. Since the remaining two angles are 60 degrees, so this will be also equal to 60 degree. So we can say that triangle BPQ is also equilateral. Triangle BPQ is also equilateral. Hence, we can say that BP is equal to PQ, BP is equal to PQ is equal to BQ. Since all the sides are equal. Since I can say that since triangle BPQ, since in triangle BPQ, all the angles are equal. So the sides, so hence I can say, so all the sides opposite to the equal angles are also equal. Angles of, so the sides opposite to the equal angles are also equal. So PP is equal to PQ we have shown. It is told that CR, so therefore you can say that CR is equal to BP, which is given. CR is equal to BP, which is given. So I can say CR is equal to PQ also. So CR is equal to PQ also. So now I will tell, now in triangle RCM. So here also we have to write that, and QR, the line QR bisect or QR intersects BC at M. QR intersects BC at M. In the given only we should write that. Okay, so now in triangle PQM, in triangle PQM, and triangle CRM, you can see that angle PMQ is equal to angle RMC in RMC. Since why they are vertically opposite angles. So vertically opposite angles are equal. And vertically opposite angles are equal. And CR is equal to PQ, and also we can see that angle QPM, that is equal to angle RCM. QPM is equal to RCM. Since why they are alternate interior angles. And angle QPM is equal to angle RCM. Since why alternate interior angles are equal. Since it is given that since PQ is parallel to RA, we can say PQ is parallel to RA, and obviously PC is the transversal. And we can also say that, and we have shown that PQ is equal to RC and PQ is equal to CR, which is proved above. So hence we can say that we have shown that two angles and the non-included sides are equal in two triangles, and so they are congruent by AAS rule. So therefore we can say that triangle PQM is congruent to triangle CRM by AAS rule of congruency. AAS rule of congruency. So therefore we can say that QM is equal to RM. Therefore we can say that QM is equal to RM. QM is equal to RM by CPCT. So hence we have shown that PM is equal to RM. So hence QR bisects PC. So hence proved. So here only we can say that QR bisects PC, or we can also show that QM is equal to RM. So if we can show that QM is equal to RM, hence it also means that M is the midpoint of QR. It means that QR bisects PC. Okay, QR bisects PC, or sorry, we have to show that QR bisects PC. It means we have to show that PM is equal to CM. PM is equal to CM. So it means that QR bisects PC at the point M, or M is the midpoint of PC. So here, instead of showing QM is equal to RM, we can simply say that therefore AS rule of congruency. So therefore we can say that PM is equal to CM. PM is equal to CM. PM is equal to CM. The reason is CTCT. So hence proof. Hence prove that AM is the midpoint of PC, or simply QR bisects PC. So hence proof. So hope all of you have understood the solutions of all these questions till question number 58. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. So thank you everyone